mengumumkan perarakan masuk diketuai oleh Timbalan Naib Chancellor Hal Ehwal Akademik dan Antarabangsa dan Profesor. Hadirin mohon berdiri. Lagu Negaraku dan Varsity Kita. Hadirin dipersilakan duduk. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Bagi memohon keberkatan Allah Subhanahu wa taala, majlis didahulukan dengan bacaan doa Al-Fatihah. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Ar-Rahmanir-Rahim. Maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين. الحمد لله رب العالمين والعاقبة للمتقين والصلاة والسلام على سيدنا محمد وعلى آله وأصحابه أجمعين. Ya Allah, Ya Rahman, Ya Rahim, dengan penuh rendah diri kami menadah tangan padamu, memohon keampunan atas segala dosa-dosa dan kesalahan yang telah kami lakukan. Ampunkanlah dosa kedua ibu bapa kami, guru-guru kami, serta seluruh mukminin dan mukminat, muslimin dan muslimat, sama ada yang masih hidup ataupun yang telah meninggal dunia. Allahumma ya Hayyun, ya Qayyum, ya Zal Jalali wal Ikram. Jadikanlah perhimpunan kami ini, iaitu Majlis Syarahan Umum, yang akan disampaikan oleh yang berbahagia Prof. Dr. Mohammad Tariqul Islam ini, mendapat rahmat dan keberkatan darimu. Jadikanlah ilmu yang dikongsi ini membawa kami lebih taat kepadamu dan mengagungkan kebesaranmu. Kurniakanlah taufik dan hidayahmu, kerana sesungguhnya engkaulah pemilik sebenar hidayah dan ilmu. Pada pagi ini kami kecapi nikmat pemberianmu, kesihatan dan perlindungan daripadamu. Maka sempurnakanlah nikmat afiat dan perlindunganmu terhadap kami di dunia dan di akhirat. Allahumma ya Hanan, ya Mannan, ya Badi'us samawati wal ard. Ya Allah, kurniakanlah kami lidah yang lembut dan basah dengan mengingati dan menyebut namamu, hati yang penuh segar mensyukuri nikmatmu, serta badan yang ringan menyempurnakan ketaatan kepadamu. Ya Allah, kurniakanlah kami iman yang sempurna, hati yang khusyuk, ilmu yang berguna, keyakinan kepadamu yang benar-benar mantap. Selamatkanlah kami daripada mara bahaya dan petaka. Kami mohon ya Allah, kecukupan yang tidak sampai kami terpaksa meminta-minta kepada orang lain. Berikanlah kami ya Allah iman yang sebenar-benarnya, sehingga kami tidak lagi gentar atau mengharap orang lain selain engkau sendiri. Turunkanlah rahmatmu kepada kami, keluarga dan anak-anak kami, serta sesiapa sahaja yang bersama-sama kami. Janganlah ya Allah engkau biarkan nasib kami ditentukan oleh kami sendiri, walaupun sekadar kelipan mata. Wahai Allah yang paling mudah dan cepat memperkenan permintaan, perkenankanlah doa kami. Selawat dan restu Allah untuk junjungan kami Muhammad, Nabi yang mulia, kepada keluarga baginda dan para sahabat baginda seluruhnya. Allahumma ja'al jam'ana hadza jam'an marhuma wa tafarruqa min ba'dihi tafarruqan ma'suma wa la taj'al fina wa la ma'ana syakiyya wa la matrudan wa la mahruma. Rabbana la tuzigh qulubana ba'da idh hadaitana wa hab lana min ladunka rahmah innaka antal wahhab. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azaban nar. Wa sallallahu ala sayidina Muhammad wa ala alihi wa sahbihi wa sallam. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin. Memulakan atur cara, majlis dengan segala hormatnya mempersilakan yang berbahagia Profesor Datuk Dr. Riza Atiq Abdullah bin Oki Rahmat, Timbalan Naib Chancellor Hal Ehwal Akademik dan Antarabangsa Universiti Kebangsaan Malaysia, untuk menyampaikan pidato pengenalan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, salam satu Malaysia. Yang berbahagia Profesor Datuk Engineer Dr. Abdul Wahab Muhammad, Dekan Fakulti Kejuruteraan dan Alam Bina, Timbalan-Timbalan Dekan Fakulti Kejuruteraan dan Alam Bina, Ketua-Ketua Jabatan, peserta-peserta sarahan, serta hadirin dan hadirat yang dihormati sekalian. Syukur kehadrat Allah Subhanahu Wa Taala, pada pagi ini kita dapat bersama-sama mendengar syarahan umum yang berbahagia Profesor Dr. Mohammad Tariqul Islam dari Fakulti Kejuruteraan dan Alam Bina. Beliau akan menyampaikan syarahan yang bertajuk Planar Antena Struktur Road to Miniaturization. Mohammad Tariqul Islam merupakan seorang anak kelahiran Dhaka, Bangladesh, yang lahir pada 1 Disember tahun 1975. Ayah beliau merupakan seorang jurutera elektrik, dan ibu beliau adalah seorang suri rumah. Beliau merupakan anak sulung dan mempunyai 4 orang adik-beradik. Pendidikan tinggi beliau bertumpu di Dhaka, Bangladesh, di mana beliau telah menerima ijazah sarjana muda sains dan sarjana dalam kejuruteraan komunikasi dari University of Dhaka, Bangladesh, pada tahun 1998 dan tahun 2000. Berbekalkan semangat untuk meneroka ilmu di luar Dhaka, beliau telah memohon program PhD di UKM. Beliau telah mendaftar sebagai pelajar PhD di Jabatan Kejuruteraan Elektrik, Elektronik dan Sistem pada tahun 2002 dan berjaya memperoleh ijazah Doktor Falsafah pada tahun 2006. Kecintaan beliau memang mendalam terhadap penyelidikan. Justru itu beliau telah memilih penyelidikan sebagai kerjaya, di mana beliau bermula sebagai fellow penyelidik di Pusat Penyelidikan BOS. Kalau Inggeris, kalau bahasa Inggeris BOS lah. Kalau bahasa Malaysia BOSE. Kalau Bangladesh BOS. Okey, BOS. University of Dhaka sebaik saja menamatkan pengajian sarjananya. Hanya 2 tahun beliau bekerja untuk mengumpul biaya sebelum bergelar pelajar PhD di UKM. Selepas menamatkan pengajian PhD, beliau terus dilamar oleh Universiti Multimedia di Melaka sebagai pesarah. Di situ juga tidak lama, hanya 2 tahun, bagai sirih pulang ke gagang. Tariqul kembali semula ke UKM pada tahun 2008, tetapi kali ini sebagai pesarah kanan di Institut Sains Angkasa UKM, itu Angkasa. Beliau telah dinaikkan pangkat ke Profesor Madya 2 tahun kemudian. Berdasarkan kecemerlangan yang telah ditunjukkan, UKM telah memberi kepercayaan untuk melantik beliau sebagai profesor pada tahun 2012 ketika berusia 37 tahun. Selepas angkasa di struktur semula pada hujung Disember tahun 2013, beliau telah memilih Jabatan Kejuruteraan Elektrik, Elektronik dan Sistem Fakulti Kejuruteraan dan Alam Bina untuk meneruskan khidmat bakti dan sumbangannya di UKM. Dari sudut penyelidikan, Profesor Tariqul amat cemerlang sebagai penyelidik berwibawa di dalam bidangnya. Beliau telah menjalankan penyelidikan dalam bidang reka bentuk antena komunikasi, antena radio astronomi, antena satelit, dan analisis sinaran elektromagnet. Beliau telah menyelia lebih dari 30 orang pelajar di peringkat Doktor Falsafah dan Sarjana. Penerbitan beliau termasuk lebih 232 kertas jurnal penyelidikan, hampir 110 kertas persidangan, 3 buku penyelidikan dan beberapa bab dalam buku mengenai pelbagai topik yang berkaitan dengan antena, gelombang mikro dan analisis sinaran elektromagnet. Setakat ini, penerbitan beliau telah dipetik atau cited sebanyak 1,672 kali dan His Index adalah 25 berdasarkan sumber Scopus. Hasil daripada penyelidikan yang dilakukan bersama kumpulan penyelidik, Profesor Dr. Tariqul telah berjaya memfailkan 10 paten. Hasil penyelidikan Profesor Tariqul juga telah mendapat pengiktirafan daripada pelbagai pihak dengan pencapaian beberapa anugerah pinggan emas dalam pelbagai pameran dalam negara dan antarabangsa. Reka cipta terbaik dalam anugerah telekomunikasi dan anugerah khas dari Vietnam untuk penyelidikan dan inovasi beliau. Di peringkat universiti, beliau merupakan penerima anugerah penyelidik muda pada tahun 2010, manakala di Majlis Anugerah Inovasi UKM pada tahun 2011, beliau merupakan pemenang anugerah inovasi penyelidikan dan sijil sagu hati anugerah penyelidikan individu. Pada tahun 2014 pula, beliau menerima anugerah penyelidikan kumpulan dalam niche ICT. Beliau adalah penerima anugerah penerbitan dari Agensi Angkasa Negara pada tahun 2009, 2010, 2013 dan 2014. InsyaAllah 2015 dapat juga, insyaAllah. Tiap-tiap tahun. Beliau juga pernah dipilih sebagai pemenang untuk anugerah pembentang terbaik pada tahun 2012 International Symposium on Antennas and Propagation, ISEP 2012 di Nagoya, Jepun. Profesor Tariqul juga aktif menganggotai beberapa jawatan kuasa, antaranya menjadi ahli kanan dalam IEEE, ahli Applied Computational Electromagnetic Society, dan ahli Institute of Electronic Information and Communication Engineers. Beliau juga merupakan Editor-in-Chief International Journal of Electronics and Informatics dan sebagai Editorial Board of International Journal of Antennas and Propagation. Kini Profesor Mohammad Tariqul merupakan Fellow bersekutu di Pusat Sains Angkasa atau Angkasa dan Institut Informatik Visual dan Ketua Kumpulan Penyelidikan Radio Astronomi Informatik di UKM. Beliau menguruskan berbagai dana penyelidikan daripada Kementerian Sains, Teknologi dan Inovasi itu MOSTI, Kementerian Pelajaran Malaysia itu KPM dan beberapa geran penyelidikan antarabangsa dari Jepun. Bidang penyelidikan semasa beliau kini termasuklah berkaitan dengan antena padat satelit kecil, teknik pengoptimuman untuk antena jarum lebar, analisis sinaran elektromagnet, antena kecil untuk sistem pengimejan gelombang mikro dan antena dui kutub untuk kajian solar. Sokongan keluarga yang jauh di Bangladesh serta isteri yang dikasihi, Farha Tabassum. Betul sebutan tidak ada. Dan seorang putra sentiasa menjadi dorongan dan sumber inspirasi kepada Profesor Dr. Mohammad Tariqul Islam untuk terus melakar kejayaan dan menabur bakti kepada UKM dan masyarakat seluruhnya. Beliau kini sedang menanti kelahiran cahaya mata yang kedua. Hadirin sekalian, saya dengan sukacitanya mempersilakan Profesor Dr. Muhammad Tariqul Islam untuk menyampaikan syarahan umum beliau bertajuk Planar Antenna Structure Road to Miniaturization. Sekian, wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Yang berbahagia Profesor Datu Engineer Dr. Riza Atik Abdullah Oke Rahmat, Deputy Vice Chancellor, Academic and International Affairs, University Kebangsaan Malaysia. Yang berbahagia Profesor Datu Engineer Dr. Abdul Wahab Muhammad, Dean, Faculty of Engineering and Built Environment. Distinguished guests, senior officers, ladies and gentlemen, Assalamu alaikum and very good morning. Today my Syarahan Umum title is Planar Antenna Structure, Road to a Miniaturization. In our daily life, we are using different types of antenna by knowing and without knowing. For example, planar antenna are used as the communication via iPhone, iPad, etc. However, thanks to the researcher of the new era, today's antenna are so compact that we cannot even realize its existence in our daily life. The compact structure of these planar antennas allow our modern day communication device so small and manageable. This existing journey from smoke signals to the information age of smart antenna is punctuated by great minds like the father of electromagnetism, James Clerk Maxwell, and inventor of modern radio, Nikola Tesla. Once Nikola Tesla famously quoted, "If you want to find the secret of universe, think in terms of energy, frequency, and vibration." Nikola Tesla. Several notable discoveries in human history since fire have been utilized in some shape or form to facilitate the communication. The inherent desire of expressing ideas, thoughts, and emotions conveniently has led to development of wireless communication technology over the last few decades. For a microwave engineer or an antenna engineer, antenna is a brushes of an artist, which is similar to like as an artist who uses their brushes to do sketch as the artist like. With the antenna, a microwave engineer can generate the signal over as he likes or demand. There are various types of antenna can be found. For example, dipole antenna, parabolic dish antenna, planar antenna, multi-layered EMC antenna. Antenna application are not limited to mobile phone only. Some of the most important application of antennas are radio frequency identification, global positioning system antenna, UWB short range. Recently, another application of antenna is very booming, that is related to biomedical engineering, that is biomedical imaging system. Planar microstrip patch antenna are very popular in mobile, WLAN, RFID, and ultra-wideband radio wireless communication. because of their notable advantage, including their simplicity, lightweight, comfortable, easy fabrication. Planar antenna can be manufactured using printed circuit technology, so mass production can be achieved at a lower manufacturing cost and can easily be embedded into wireless device or integrated circuit. The scope of this lecture is to highlight the research work performed by my group at University Kebangsaan, Malaysia. The primary aim of these research activities are to strengthen Malaysian participation in designing and developing communication devices to fulfill the ever-increasing demand of the modern wireless communication technology. My research focused on the design of compact planar antenna for RFID reader module, as RFID is promising technology in Malaysia for tracking and tracing of assets, documents, personal vehicle, luggage, laundry, high-value electronics such as computer, TV, even in security guard house in residence. RFID plays a vital role for the industry for logistic and bioengineering application, along with its traditional asset and personal tracking application. The integration of RFID system within the supply chain of company offers an abundance of economic and productive capabilities, can be seen from figure. Different objects and items of various shapes and size can be encountered through the RFID application. Asset management, machine inventory management, good management in shop, containers, and vehicle tracking, and escalator monitoring, item level identification can be done by RFID technology in figure. It is one of the fastest growing wireless system market in the world. Recent findings of RFID global market show that in 2008, the total RFID market was worth of $5 billion, up from 19 billion in 2013, and also indicate RFID market price will rise of 28 billion in 2018. The impact of RFID and in socio-economic benefit in Malaysia through wide-scale deployment of RFID is shown, can be seen from here. My research also focuses on planar design on 5G, which is future generation mobile communication. 5G is best described today as a generally agreed set of new requirements for wireless communication system that will mature beyond 2020. However, there have been a broad consensus on what the general requirements are. Starting with the speed, researchers are talking about 10 gigabits of, which is 100 times faster than the existing 4G. A very low delay, about 1 millisecond, instead of 10 to 15 milliseconds and watts that we have today. High mobility and high density. It's like 70,000 people using their smartphone with the high speed. And finally, low cost, low energy, large device count for Internet of Things. So the 5G will likely be described by most revolutionary technology, not evolutionary technology. The two main reasons for that is it will have multiple radio access technology like combination of cellular technology, Wi-Fi technology, and others. Millimeter wave for higher bandwidth of massive multiple antenna technology with hundreds of antenna to ensure such speed. In this revolutionary technology, that the most important thing will be the multiple number of radio access network. We can see the radio access network. People can get access to the service by using Wi-Fi, WLAN, cellular technology, optical fiber, even satellite communication. Random access point will be available at the nearest distance, which provide quality service and require transmission power. Device will be very smarter. Like our refrigerator will send data about the grocery item, whether our red meat is finished or we have still white meat. Our alarm will tell our curtain when to open, and our coffee maker when to start the morning brew. All these devices will be connected through this random access point. We can see even the cat has a sensor to get this data. Multiple antenna technology uses higher number of antenna that will give high reliability, higher throughput, and lower transmitted power. Deployment of this small cell will be higher and will lifting the mobile traffic load from outdoor macro cell. Providing this service will be easier and cheaper for operator throughout the world. For implementation of multiple antenna in 5G, directional antenna will be required, which will also bring a new concept of mobile device. Usually, the mobile device is omnidirectional. Propagation through material and interference management is also very vital. Another most important feature, it will have the capability to move the signal vertically and horizontally. For such cases, estimation of direction of arrival of the user is very vital to know the prior knowledge of the users from the cell end. Right now, we are working on direction of arrival estimation for 5G frequency using such multiple antenna structure. Recently, ultra-wideband technology has shown high potential for a wide variety of new applications to provide significant improvement in public safety, business, and consumers. It has generated tremendous interest in both industry and academia. These applications include WLAN, wireless personal area network, wireless body area network, I1, wireless sensor network, high accuracy radars, and imaging systems. In aircraft cabin management system, the core service will be provided by UWB wireless communication system. For example, audio announcement, information display, reading light, cabin video monitoring system. By utilizing this ultra-wideband wireless system, the installation of equipment can be reduced. The maintenance cost will be low and weight will be reduced since the communication device inside aircraft will connect without wire connection. So it will reduce fuel consumption. So aircraft will be fuel efficient if we can use UWB antenna system. Another application that we focus by our group is microwave imaging system. The ultra-wideband microwave imaging system is getting very much popular in modern day medical application. It is also a replacement of the typical imaging system because of the certain limitation they had. For example, X-ray provide ionizing radiation. Infrared is also limited to the surface of the objects. Magnetic resonance, which is called MRI, is very expensive, whereas microwave is utilized due to its very low power and non-ionizing radiation, high penetrating power, and low cost above all. Recently, microwave imaging has been used extensively for medical imaging applications such as breast cancer detection, heart failure detection, brain stroke detection. Moreover, this system has also been used for industrial training. Another application in our research, we focus for small satellite development. A communication satellite, traditionally large satellites like Rajaksat, more than 100 kilograms, were developed for fast communication over long distances. But you can see nowadays we can even lift the small satellite by the but they are very costly to develop and deploy into orbit due to the large size, mass, and production cost. Miniaturization technique have opened up a new avenue for satellite communication by decreasing the size and cost to create small satellite. These facilities can be characterized by their size and mass. Satellites that have mass of few kilograms are known as microsatellite. Based on the development time, mass, and cost, it can be classified as like large satellite, medium satellite, microsatellite, nanosatellite, and CubeSat. Their application is extensive, varying from telecommunication, space science, Earth observation, mitigation, and management of disaster, for example, flood, fire, earthquake, military application, education, and training. Most small satellites are launched in low Earth orbit, which is about 400 kilometers from the Earth's surface. We can see that the launching history from 2000 to 2016, it is increasing. In 2015, there is a plan to launch maximum small satellites so far. Projection shows a range of 120 to 188 nanosatellites will be launched by 2020. In country-wise, like USA so far launched as usual, 95, Japan so far 24, in Asia, Saudi Arab 8, and India so far 5 satellites is launched. Malaysia has planned to launch with the Rajaksat a small satellite which was failed in 2006. Basic differences in all the application of antenna, basically difference in frequency fundamentally. All the application, also different variety of radiation pattern is required by several applications. It is the physical phenomena where an electric and magnetic, what is electromagnetic wave in frequency? It is an electric and magnetic field oscillates in a wave-like manner. Consider a stone. throw into a motionless pond, a circular wave is generated along the surface of the pond that propagates radically outward from the point where the stone fell. Electromagnetic waves behave in similar manner. They radiate outward from an antenna structure, which creates an electromagnetic disturbance. The electromagnetic wave can be characterized with frequency. Ratio of vibration or oscillation of the electromagnetic wave is known as the frequency. Frequency is expressed in hertz, number of oscillation per second, and has several prefixes such as kilohertz, megahertz, gigahertz, and terahertz. It is seen different frequency range is used for several applications. For example, the research we focus in RFID frequency. Malaysia is occupied 919 megahertz to 923 megahertz. For ultra wide band, it is quite wide band frequency from 3 to 10 gigahertz. 5G communication not yet finalized the frequency. They have target to finalize by the end of this year. One of the famous few frequency slot is like 28 gigahertz, 38 gigahertz, 70 to 85 gigahertz, and 90 to 95 gigahertz. Presently, in our daily present mobile, we are using 900 megahertz to 1900 megahertz. These are the different types of radiation pattern, which is depend on the application. Like for small satellite has a different types of radiation, and ultra wideband has another types of radiation, and 5G has another types of radiation. It can be omnidirectional, unidirectional, or bidirectional radiation. This is the fundamental difference with the different application. Planar antenna, as I shown in earlier, that iPad antenna, it's like the antenna which is in a single plane. The antenna is usually generate signal efficiently. Any conducting element or any structure that is like aluminum, steel, gold, silver, through which current can propagate, may be used as a radiating element of an antenna. The current propagates through the patch, which is radiating element, and returns through the ground plane, one of the important parameter, the part of the antenna, ground plane behind the antenna, to complete the loop. The antenna can consider an electrical device which convert electrical power into radio waves and vice versa. It is usually used in any radio transmitter or radio receiver. Antenna design for ultra-wideband application is facing an enormous challenge due to its wide operating bandwidth. One of the challenges is the size of the antenna for handheld device, because the size of the antenna significantly affects the bandwidth and gain. Therefore, design of compact antenna that are capable of achieving ultra-wide frequency range or bandwidth with stable, acceptable gain is still a challenging task of antenna designer. A planar design, which is one plane, can usually be used to reduce the size and volume of UWB antenna by replacing three-dimensional radiating element with their planar version. The radiating element and the size and shape of the ground plane, as well as the feeding structure, can be optimized in planar antenna design to achieve wide frequency range. This is called the frequency range. The planar antenna consists of a planar radiator and ground plane. The electric current in these antennas are distributed on the radiator and on the ground plane, resulting in radiation from the ground plane. Therefore, the parameter like operating frequency range, gain, radiation pattern or on the planar UWB antenna are dependent on the size, shape and the ground plane. Challenge in planar antenna design is narrow band, usually it is like 1 to 2 gigahertz, low efficiency and low gain, about 1 to 2 dB. So the main challenge is to increase these things. So we introduce a new innovative technique to achieve the best performance in wide frequency, wide range of frequency. We proposed initially the reduce the ground plane, not per full, the half ground plane. This is first we propose. The partial ground plane exhibits high current density at the upper edge, below the feed line. This is feed line. Thus, the rectangular slot was introduced. Here we introduce in partial slot, which allow more efficient radiation. Further studies showed that introduction of sawtooth or triangular, like these types of, if we use multiple sawtooth shape, provide a wide band coverage, very simple modification, as it produces the most evenly distributed surface current. As I said earlier, that we play around with the current distribution, how the current moved inside the radiating element. The partial ground plane also allows an omnidirectional radiation pattern, but in complete ground plane, if we use full ground plane, it is only unidirectional radiation pattern. We can see that by using the full ground plane, it is only 34% of bandwidth. But if we reduce the ground plane of 22 size, it is about 34. But if we reduce to 7.5, 30 by 7.5, it is 109. If we use one slot, we get 117. But if we do the triangular slot, we get about 135. This is the prototype of this. Okay. Another innovative technique we develop here, the patch shifting technique. It is seen that shifting of patch from the substrate, this is the middle, but we shift slide left side, can center into this wider frequency event. Main challenge to control the gap between this gap, the partial ground plane and here, this gap to between partial and radiating plane. This is due to the lowest frequency become wider. It is basically due to the resistance is modified. By using shifting the patch, we modify the resistance. Usually current flow in one direction. You see the current flow in one direction only. We have another types of polarization which is called circular. Sometimes within this very wide band, there are several other narrow band also exist. For example, Wi-Fi, WiMAX, WLAN. So these existing narrowband service may cause interference with this UWB system. To realize the band cancellation, we propose a triple band cancellation by using 3 resonant elements, just 3. One is C shape, E shape, and open circuit. This one we incorporate in the behind of the antenna. To cancel the first frequency band in WiMAX, we just edged out E shape element. To cancel other 2 frequency in WiMAX, we use the open stub and the C shape. We just incorporate behind the ground plane. The cancelling frequency band characteristics of the proposed antenna can be controlled by properly adjusting the parameter, this parameter, at the back end of this patch. We publish this work in IEEE Antenna Wireless Propagation. You can see the prototype. This is one of the example radiation that current can see in 3D pattern. In RFID, a key issue with RFID reader antenna is the read range. This determines the maximum distance from which it can read a smart tag or signal. Normally, the normal tag detection, you have to roll down your car window and reach out and touch your access card to read the antenna when you arrive at your access point of your residence. But we have managed to develop a reader antenna that can read smart tag up to 7 meters far away. Thus, it would be able to read your access card from inside your wallet even, which would be inside your pocket and on the other side of the door. We measured in FKB car parking the distance. RFID planar antenna design is using circular slot, so we no need to go approach to the tag, smart tag. Even from the far you can detect. This planar antenna we design with this circular slot with the microstrip line feeding and triangular shape feeding. The configuration of these 2 strips, triangular and this microstrip feeding on the circular slot, produces a high charge density at the top tip. This fine sharp help us to do the matching and high radiation efficiency and high gain, thus longer read range. This is the beauty of this design, is managed to get this longer read range. The feeding structure provides significantly more design flexibility. The resonant frequency can be adjusted by varying only one parameter, which is this angle. By changing this angle, we can vary the resonant frequency. This is the prototype. This is the marketable prototype. We usually use measure these types of antenna in the control environment, which we call anechoic chamber. It is in our department. We have this lab inside Jackis. Small satellite antenna research. For small satellite antenna design, we have some challenges. Like antenna must be highly reliable, very small, have low mass, by highly efficient, and have to be low cost. The thermal design of the antenna must be carefully designed to perform wide temperature variation because of the microgravity environment, roughly like 150 degree to 150 degree plus, minus 150 degree to plus 150 degree. Antenna must be able to survive in harsh condition, environment in space such as ionizing radiation and solar energy particles. Effects of atomic excision need to be considered also for low Earth orbit, which is 400 km from the Earth's surface. Material for the antenna also need to be chosen carefully, considering the effect of vacuum and microgravity. 4 asymmetrical V-shape, 1, 2, 3, 4, this V-shape, slit in the diagonal direction on the square patch, and a parasitic element, this is called the rectangular. Parasitic element are introduced to design the satellite antenna. All these combined effects create satellite to work in circulation condition on Earth and desired frequency. The radiation pattern here is called circular. If we can see the current distribution, the current is moving in circular direction. This work is consultancy work and research collaboration work from QTech, Fukuoka, Japan. We are developing the antenna for their microsatellite, which is named as Horio 4. That will be launched in this year, December 2015. 2 S-band antenna is attached to the satellite body for transmitting application. One is the top and another is the left side of this, here and another. After integration of these 2 antenna through non-conducting glue with the satellite body, different tests performed in the Laboratory of Space Environment Interaction Engineering, QTech, Fukuoka, Japan. Several environmental tests are conducted in QTech lab on overall satellite structure. Atomic oxygen test, plasma environment test, microwave test, thermal vacuum test, and mechanical stress test. These are the testing chamber to ensure it is capable of sustaining the acceleration and vibration experienced during the launch process, because it involved a lot of vibration process. No visible cracks were observed on the satellite antenna after the rigorous environmental and mechanical test. To design these types of antenna, it is involved huge computational complexity, hours of human interaction. The satellite antenna was developed using an optimized algorithm, our own algorithm, which is called RAM convergence. The optimized design shows the feeding position move from middle to upward by using the optimization as about half distance to ensure the matching. The result is involved the current matching. The 2 parasitic strips, initially the 2 parasitic strips included as reflector on both sides of the V-shaped patch, 1 and 2. As it was uncertain which direction the feed will move before we do the optimization, our proposed algorithm. Then after we optimize with the proposed, we found that it shifts the feed to top direction and removes 1 reflector. We see that finally it removes 1 reflector. From the data we can see it gives 0 values. So it removes in the optimizing algorithm is 1 reflector. To make the design simple and make antenna circular radiation, because the satellite is moving on the Earth, so we need the circular radiation. 1 reflector is eliminated by algorithm. The beauty of this algorithm is that the existing algorithm, optimization algorithm like PSO, have few drawbacks, especially that it is early convergence. Before it matures, it becomes convergence. And the RCPSO is used for multi-start base to avoid premature convergence, our proposed algorithm. And the existing algorithm also has a cuts of dimensionality, that it can only handle 6 to 7 dimension. But for example, if the complex antenna like 30 dimension, then it can be reduced to similar like 6 to 7, and before one cycle complete, then it goes another cycle and it can converge and can optimize. We will publish this result in IEEE antenna propagation. Another types of antenna design we use for microwave imaging. As we said that the existing imaging is very ionizing issues and very expensive, like for example MRI. We use the metamaterial concept, metamaterial antenna. This antenna is type of antenna that uses the metamaterial. Metamaterial is artificial material engineered to have properties that have not yet been found in nature. It is basically not a material, it is basically a circuit. This antenna is designed with a metamaterial unit cell for ultra-wideband microwave imaging application. It has a characteristics of negative permittivity and permeability, the negative values. This antenna consists of a radiating patch of 4 unit cell, 4 of each unit cell, with modified split ring resonator. The resonator is here. The SRR is constructed using 2 loops. Total dimension of this antenna is only 21 millimeter. It is tremendously achieved with this compact antenna with a very wide band, that means longer band from 3 to 15. The improved bandwidth and radiation characteristics of the proposed antenna are achieved using this design technique. The reported figure shows the validation of the ultra-wideband performance and current distribution. We also do radio astronomy research to detect solar flare from sun. Tracking the solar flare is extremely important. High energy particles ejected by the sun causes solar flare due to instability of magnetic field in sun. It causes disruption of Earth-based communication, damage to orbital satellite, dangerous to astronaut, destructive surge on power grid. If we can detect solar flare, that can manage orbiting satellite to be in safe mode. Power grid operator can configure their system to limit the damage from huge current. Solar flare can be observed utilizing dipole-based antenna in the radio telescope system and with dish antenna. A multi-volt dipole-based antenna based on V-shaped driven element. We measured it in the badminton court of Jackies for low, because it is very big and our equipment cannot make it out, so we measure inside. In this system, the traps were developed using discrete component comprising inductor and capacitor, constructed in a planar surface to get different band, which is called multi-band. These traps structures are inserted directly between the antenna element. The low frequency Callisto receiver is installed in Permata printer inside UCAM, since the radio astronomy need a radio quiet zone, so called, so we cannot get that much quiet zone. So we found that Permata printer is quite further from the main place of the UCAM, so we choose that place. And a 4.5 meter dish is installed in the rooftop of UCAM research building, which is the biggest and only radio telescope in Malaysia. We installed this with the help of Agency Angkasa Negara, mostly. The system is connected to the international database through Zurich Institute of Technology. Any researcher can download our data from the system through their database. Geographically, Malaysia has advantage since we are situated in equatorial region. Northern part of the world is always looking our data because they are night time, we have daytime. So during that time, they are missing their data, own data, so they cannot observe the sun during their night time, so they rely on our data. So far in radio astronomy, Australia and Indonesia provide a good data for their solar study. We have observed a major solar flare, which is called X 4.9 in February 25, 2014. And this solar flare is observed in Alaska and only UK Malaysian station, the only station within the Callisto network that detected this radio signature of the solar burst. We published this IEEE magazine of this April of this data. We also do research in radiation analysis. The radiation effect of human body. Rapid advances in personal communication industry and huge use of cellular phone have increased concern about the effect of radio frequency radiation on our public health from these devices. Electromagnetic radiation pollution. Human head is one of the most sensitive organs for electromagnetic radiation. Due to all these uncertainties, research on the electromagnetic radiation in human head has carried out extensively because of the public concern that thinking that too many devices are using, so how will be the effect of health? The electromagnetic absorption rate, the radiation in terms of SAR, is a value to evaluate the power absorbed by biological tissue. The World Health Organization, which is called WHO, is determined this value of in two unit. One unit, it is called, the value should not be 1.6 watt per kilogram, and another unit, it should not be 2 watt per kilogram of the tissue. So these two value is considerable. If the value is more than that, there will be a probability of the rise of temperature, head tissues temperature, like insomnia, fatigue, headache, migraine, brain tumor, and brain cancer. The electromagnetic radiation can be reduced by placing our proposed planar triangular shaped metamaterial between the human head and the mobile phone. The triangular metamaterial is developed based on the triangular shaped structure. In Malaysia, we don't have the measurement facilities. We measured in United States America in the COMOSAR system. Because human cannot expose to the radiation, so the robot is used in the measurement system. The phantom of head and different liquid is used which represent the body dielectric constant, because human cannot expose during the measurement time. And we measured the electromagnetic radiation in terms of specific absorption rate. We found that our result, where it is recommended by World Health Organization, is 1.6, we found 1.017, very low, by using this triangular shaped metamaterial if we incorporate in the mobile set. And for another unit, for 10 gram, we found that it is only 6, whether the World Health Organization assigned for 2, we achieve 0.676 only power of radiation power. So we can say it is quite safe to use. This is some more result of simulated, that you see how the current is heated nearby the air when we talk longer time. And these are the measured results that just now I mentioned, which we measured in COMOSAR, the electromagnetic radiation around the head. With this all invention, we have filed few patents through UCAM. I would like to thank UCAM. They give the opportunity to file all these inventions. We are also doing research collaboration in internationally, national and industry level. For the international research collaboration, we do University of Waterloo, Canada, Kyushu Institute of Technology, QTech, Japan, National Defense Academy, Japan, NDA, King Abdulaziz University, Saudi Arabia, and University of Hong Kong. Sometimes we go there to measure our prototype. We have national collaboration. Firstly, I should say Malaysian National Space Agency, Angkasa Negara, Wireless Radio Access Science, UTHM Center, and we do wireless center in UTM, and recently we do some collaboration with UITM. We have industry collaboration in nationally at Astronautic Technology, ATSB, for the satellite research, and radio sys technology, Jalian technology, and international industry like Raytech, Shenzhen, China. Finally, I would like to acknowledge and would like to express my sincere gratitude and in-depthness to University Kebangsaan Malaysia for accepting me as a lecturer and researcher throughout all these years, and my appreciation for all the support which has been given by Department of Electrical, Electronic and System Engineering and Institute of Space Science, Angkasa. My special thanks to Professor Datu Engineer Dr. Abdul Wahab Muhammad, the Dean, Faculty of Engineering and Built Environment, and Professor Dr. Muhammad Alauddin Muhammad Ali, ex-director of Angkasa UKM, for their constant encouragement and help. My heartful appreciation goes to all my postgraduate students in my lab. I would like to thank all my colleagues and friends of Department of Electrical, Electronic and System Engineering and Angkasa for providing a relaxed and pleasant research environment. Grateful acknowledgement is also made to the reviewer for their constructive suggestion to improve the readability of the manuscript. Last but not the least, I owe the greatest debt to my parents, wife, son and families for not only their never-ending affection, love and patience, but also their encouragement and unconditional support to me in my all effort. Terima kasih. On behalf of the university, it's my honor, Yang Bahagia Professor Datu, to receive this lecture book.
Hadirin yang dihormati sekalian, demikian tadi syarahan umum sempena pengukuhan jawatan profesor oleh Profesor Dr. Mohammad Tariqul Islam dari Fakulti Kejuruteraan dan Alam Bina yang bertajuk Plana Antena Struktur Road to Miniaturization. Majlis merakamkan ucapan tahniah dan sekalung penghargaan kepada Profesor Dr. Mohammad Tariqul Islam atas syarahan tadi. Temukan kemuruh untuk yang berbahagia Profesor. Mengumumkan perarakan keluar diketuai oleh Timbalan Naib Chancellor Hal Ehwal Akademik dan Antarabangsa dan Profesor. Hadirin mohon berdiri. Seterusnya, hadirin dijemput menikmati jamuan yang disediakan di bilik bangkuasi serta melawat pameran di foyer Paras 1. Sebagai makluman hadirin, buku syarahan boleh diperolehi di luar bilik senat ini. Setinggi-tinggi penghargaan dan terima kasih kepada semua yang meraihkan majlis syarahan ini yang penuh bermakna. Sekian, majlis memohon diri.
Doid bhai. আপনারা কি বলছে সবুজ ভাই? এটা নিয়ে যেতে বলছে না? না আমি নিজে শুনলাম। Oh,